Hello again, and in this video we'll be going over object-oriented programming concepts such as encapsulation, inheritance, polymorphism and abstraction in Python. Let's start with encapsulation. Encapsulation is the idea of bundling data and methods that work on that data within a unit, so a class, and it can be used to hide internal representation or a state of an object. We can have different levels of encapsulation. We can have weak encapsulation using public variables or methods where a class and anything outside that class can access these. We can have mid-level encapsulation using the protected variables and methods, and in this case the variables and methods can only be accessed by its own class or any child class derived from it. And we have complete encapsulation using private variables and methods where only the class itself can access them. So the variables and methods are completely restricted. So let's create a class car and let's define the initializer for this class. Now for a public variable we can do self dot and then let's call it type, and we'll set the type to be a sport car. So public variables do not have any underscores before them. Now if we create a protected variable, we put a single underscore before the name. So let's make this automatic and set it to false. So the single underscore indicates that this is a protected instance variable. And let's finally create our protected variable. And for protected variable we use two underscores and we'll call it max speed and set it to 200. So that's how you can create public, protected and private variables. Now we can use the exact same concept for methods. So to create a public method we use no underscores, so let's create a public method drive which prints driving, and let's create a private method update software, so we do def, and for private it's double underscore update software which prints out updating software, and for protected you would use a single underscore. So we created a class car with its data and methods defined in one place. Now if we create a car object using a car class, we can access the public method drive. So let's give this a run and you can see that it prints out driving. Now if we try to access the update software the same way, so let's do underscore underscore update software and try to give that a run, you can see we can't call it, and that's because it's a private method. But this method isn't completely restricted, because if you did want to call it you can do underscore and the class name which is car and give that a run, and that'll work for you. So that's how you can achieve encapsulation in Python. Now let's look at inheritance. Now inheritance gives us the ability to reuse code, as classes can inherit functionality and variables of other classes. So you can have a parent class or a superclass, and the classes that inherit from these classes are called subclasses. So let's say we have a class animal, and this class has two methods defined. So the initializer, which takes in a name, and another method talk, which prints out the noise that animal makes. Now if we wanted to create another class like cat, we can make use of the functionality in the animal class by creating a subclass of the animal class, which makes sense because a cat is an animal, and whatever attributes a general animal has, a cat should have as well. So let's create our cat class and let's inherit from the parent class animal, and we can do that by including it in the parenthesis. Now if we wanted to inherit from multiple classes, we can also do that because Python supports multiple inheritance. And the way you do that is you just pass in all the classes that you want to inherit from as arguments. So let's say we have another class 1 and a class 2 that we want to inherit from. We can do it this way. For now we just want to inherit from animal. And let's not define anything, so let's put pass here for now. Now let's use the cat class to create a cat object. So let's do c equals cat. Now we haven't defined an initializer here, so we'll be using the initializer of the superclass, which is this here. Now that requires a name, so we'll have to pass in a name here. And even though we haven't defined the talk method in our cat class, we inherit that functionality, so we will be able to do c.talk. And let's give that a run, and you can see that it prints out the animal makes noise. Now we can make the functionality talk more cat-like in the cat class by overriding the method. What I mean by overriding a method is when we change the implementation of a method, that's overriding a method. So let's make the cat object say meow instead of a generic noise. To do that, we just define the talk method in the subclass cat, and let's print meow instead. Now if we give that a run, you'll see it says meow instead of the generic making a noise. We can also add additional instance variables which make sense in the cat class but not in the animal class, like fur type, because not all animals have fur but a cat does. And to do that we have to override the initializer of the parent class. So let's define the initializer. Now the parent class requires a name, so we want a name when we initialize the cat class, and we also want to have a fur type parameter. Now when we override the initializer of the parent class, we have to invoke the init method of the parent class as well. So let's do animal and call the init method. And the initializer requires a name, so let's pass in the name that we get from the cat initializer. Now here I've used the class name explicitly animal, but we can also use super. What the super function does is it finds the parent class automatically. Now let's define the instance variable fur type and set that to be the argument passed in. So now we have to pass in the fur type as well. So let's just put short, and we can print out the cat's fur type. Oh, a capitalized S here. So that super is lowercase. Let's give that a run. And there we go. So that's how you inherit from a superclass or a parent class and override methods. Now let's look at polymorphism. Now polymorphism is the ability to leverage the same interface for different underlying forms. So in the Java world you can define a list of animals, but you can also add different forms of it. So you can add cat, dog, fish. Now this is easier in Python because Python uses dynamic typing, which means we don't have to declare the type of the list when we create it, and the type of that variable can change through the code. But we can still utilize polymorphism in Python when we have commonly named methods across classes and subclasses. So let's create another subclass dog, which inherits from animal. So let's do class and dog, and let's inherit from animal, and let's override the talk function here as well. So talk, and we want the dog to say woof. Now let's create a list of different objects that have a common superclass, which means they will share all the public and protected methods of that animal class. So animals, and a list which has a cat, another cat, and a dog object. And we're missing a parameter here, let's just put that in. Now with the concept of polymorphism, we can loop through the list of different objects using the same way to access the name and method called talk. So let's do for animal in the list animals, and let's print out the animal name, and let's make the animal talk. Let's give that a run. So you can see it prints out each animal name, and it also prints out meow for all the cats and woof for the dog. Now finally let's look at abstraction. Now an abstraction is a concept that can have one or more implementations. For example, generally an animal can make a noise, but depending on what species it is, this noise will change. Since we don't know what noise the animal makes until we know the species of the animal, we can make the talk method an abstract method. Now to do this, we can replace the print animal make noise with raising a not implemented error. So if we don't implement the talk method in dog, and let's create a dog here and try to call the talk method and give that a run, you can see we get a not implemented error. Now the animal class could be considered an abstract class as it has a method that is not implemented, but unlike a true abstract class, we are still able to instantiate an animal class, and the dog class can still instantiate without implementing the abstract method talk. To make animal a complete abstract class, we can make use of the abstract base classes module, ABC. So from ABC, let's import ABC meta and abstract method. Now to make animal an abstract class, we have to pass in the ABC meta to the parameter meta class. And to make talk an abstract method, we can decorate it with abstract method. And because we have the abstract method decorator, there's no need to raise an error anymore, so we can just have pass here. Now if we try to instantiate the animal class and give that a run, you can see we can't instantiate the abstract class. And if we try to instantiate a dog class where the abstract method isn't implemented, we get the similar error when we run it. So we can't instantiate an abstract class dog. But if we implement the abstract method, so let's just define talk again and try to instantiate dog this time, you can see we can do that successfully and we can call the method. So that's how we can utilize basic OOP concepts in Python. If you have any thoughts or questions on my OOP implementations, please pop them down in the comments below. In the future batch of videos, I'll be covering data structures with implementations in Python. To stay informed, hit that subscribe button, and I'll see you in the next video.